Welcome to Analytics with Nags. In this video, we are going to see about what is star schema and why the star schema is so important in data warehouse or modeling part. Let us see in this video. If you are new to this channel, hit the subscribe button right now to learn the concepts in SSAS. We are in BI architecture now, and you can see here where the star schema comes over here is like the star schema has to be created over here, that is in data warehouse. Let us come from the beginning. So the data sources have databases. So these systems are meant for running your business fastly. So these systems are optimized for insert, okay, that is OLTP systems, and the modeling used here is entity relationship model. Whereas in the data warehouse layer, in this layer, you need to convert your data into a modeling called star schema or dimensional modeling, where if you create it, the performance will be faster because this system is meant for reporting. User is always going to select rather than inserting. Your insertion or ingestion will happen during the off time, like during the night time after business hours, but always during the business hours people will keep on questioning or asking select queries. So it should be optimized for select queries or querying. So the ultimate aim of building a data warehouse is to create a star schema. So how many star schemas you need to have? It depends upon your modules. Basically consider a sales module. You have a fact for sales, and it can be a different reselling or something like return. For that, there can be two different facts surrounded by sales module dimensions. It can be a location, who is the customer, date, and products, what products. So this is your star schema. And for HR module, you can have another fact table surrounded by its own dimensions. So it is like how many modules or subject areas you have, that many star schemas you can have. It purely depends upon your business. And also the each star schema subject area I'm saying is called your data marts. In your data marts you can have multiple fact tables. Sales is considered as one data mart, HR is considered as another data mart, finance can be another data mart. So each data mart is nothing but your fact tables and its related objects. With this note, let us move on to some new I want to introduce some new concept or new terminologies so that it will be familiar. So in data warehouse world, these are two terminologies everyone should aware, that is fact or measures. So fact is nothing but what you want to analyze is your facts, like what is my sales, what is my profit, what is my customer's preference. So these are the numerical quantities that you want to aggregate and see. That is what your facts. And dimensions is like by which you want to analyze is your dimension. Meaning like I want to analyze my sales by location in different perspective or different angle. I want to see these measures. That is what your dimensions is. So sales by location, product or period, and I want to see my total profit by this location and in this product for over a particular period. So this is what your fact and dimension is all about. So we have a one fact table surrounded by different dimensions. That is what your ultimate aim of building a data warehouse for each subject area. Let us try to understand more about it. So typically, this is a classic example of sales table of some garment shop. Assume it can be a garment or any other retailer, right? So assume it can be a garment, okay? So it can be like this is like receipt number and which location, and these are the customer information, and this is your product information, and these are the some numerical quantities like measurable quantities, item price, quantity, tax amount. So having the information like this is fine, but you see like there are a lot of disadvantages of having this information, like customer name, everything. This customer name is entered if he is entering for the first time, and if he is again he is visiting, the name is repeated over here, right? So the modeling in this is the application level modeling. How they want to do is like they want to separate these entities in different tables, so you no need to maintain this information, the customer GST number, mobile number, at each of the transactions. So that is what an entity relationship model is. Similarly, for product, you need to create some master information and store it. Okay, so when you store this information like this, you have a data repeated, as I said in this example, and memory consumption is more. So the optimized way of storing in data warehouse is to convert this table. Basically, this is how a table looks like in your business, that is OLTP system. Basically it will not look exactly the same for each of this information. There will be separate tables, but it will be more optimized for insert. Okay, that is to understand. I have used in a single table. So our aim is to convert into a star schema. So this is the table, input table, I mean the source table that at the top. We need to convert into this form. Like this is my fact table. What it will contain? It will contain the key columns here, like receipt number and location. Also, you will have another dimension. Forget about it. It's a mistake here. So customer, what you are to doing is you will take the distinct values of customer and generate a numerical quantity here. You see here one, and for product, if you take a distinct values and generate some encoding value instead of saying storing the values as something like a text. Okay, so you assign some values over here, that is numerical values, that will have less storage. Basically a character will take 8 bytes, whereas integer will take 4 bytes. Assume you have a product name that has something like car or supercar. Assume like that. So supercar contains super 5 characters, and car is 3. So 5 plus 3 is 8. So each character takes 8 bytes. So 8 into 8, 64 bytes it will take. Whereas the integer value will take only the 4 bytes. Integer can store something around some million values. I mean to say like 32, how a value, a power of 32. So it will store something some million values. So from 0 to some million, it will have only 4 bytes. So instead of having 64 bytes, in 4 bytes you can refer this particular values. So convert your all your values into your unique values, like assigning some integer values here. This is your dimension table. So each dimension or master table you need to convert like this, assign a keys in dimensions. Then you have to look up and generate your fact table referring this key columns instead of storing the actual values. Say for example here, instead of Naga, I assign the value as 1 here. Okay, for Naga this is the 1 here. So 1 will be stored here instead of Naga. So my fact table size will get reduced. So this is just giving you the idea of how the star schema, how you need to populate star schema. So let us see in next screen. Like this is how it should look like. Your fact sales will have all your foreign keys, nothing but your these tables are considered as primary key tables, like For each product you will have one entry, for each customer you have one entry, for each date you have one entry, and this column is considered primary key, and this will be referring your foreign keys, I mean the fact table, because it will have a duplicate and it will repeat it, right? So same customer, I mean different customers buy same product, so this customer also buy 302, this customer also 302. Basically this primary key is referred here in the fact table, so it is called a foreign key. So all this fact table will contain the foreign keys of your dimension tables, and your dimension table have your primary keys over here. So this is what we call it as task schema. So basically from entity relationship model, you need to convert your one of the module into task schema. That is what it is. Then what happens, there are advantages, like you are referring only the numerical values here. Okay, so in your fact table you will refer only have your integer values. So all these key values are reference primary keys. The primary key obviously it will be integer values, and you have only the measures is something you are aggregatable, that is also numerical values. I'm going through walk through the how from a source table it is converted into star schema using a Adventureworks database. Let's try to launch this Adventureworks database and check how this database looks in OLTP system, and it looks how it is implemented in data warehousing as a star schema. Let's jump into a demo. Let me launch SSMS. So I have a latest one. Let us go for it. Management Studio. It will take a couple of seconds. Okay, so here choose the database engine. I hope we have multiple services, right? It's a database engine or analysis services, whatever you have installed. In this case, you go for database engine, and this is my server name. Let's try to connect it, and you can see the list of databases over here, like Adventureworks and Adventureworks DW2014. This basically, this is your OLTP system. In our architecture, if you want me to explain, this is the part. So this Adventureworks database, whatever we are seeing here, it's basically the OLTP system, the source. Okay, from this we will populate this data warehouse. So this is my personal system, so I have both my OLTP system and data warehouse in the same server database engine. In normal scenario and in organization, this will be in one server, that Adventureworks, and Adventureworks DW will be in another some server, completely in new server. Okay, so this is again, it's going to be a database. Okay, so assuming this is in another server, so you need to connect same like how I connected here. This is the server name, so this database will reside in there. So these two is available in the internet. You can download it using MDF file. Now what I'm trying to explain, so let us try to see the structure, how this tables look like. So this is my OLTP system. As I mentioned before, this system is meant for optimizing your business. So you see here all the tables are in entity relationship model. So to explain it, I think we can have some diagram over here. Let me see here. Yes, so not it's not having a diagram, that's fine. I think in data warehouse we can see it. So basically these columns, let us take one of the module like sales header. You can see here there are two things. One is header, that is having all the information, like let us try to query it, then you can see it better. So here you have some data. like order date, and you have something like a due date, ship date, status, online. Everything is number, I mean purchase order number, account number, customer ID, sales person ID. Okay, so all these things are available here, and for this you have some of the related tables. Okay, so here assume you have shipment method, so you can go and see here shipment method. Where is that? That is not a correct one. Let us go for territory ID. So you have say a territory ID. Here it is like sales territory ID. So here you have IDs here. Let us try to query it. You see here territory ID is 1 2 3 4 5 6 7 8 9 10, and these are the different areas. So that is what it is referred here. So here also they usually create some primary and foreign keys. So when you have advantages, like you assume here instead of salesperson ID, instead of integer in your entity relationship model, you are having the person name itself. At that time your data warehouse will be more optimized. This is properly designed, the Adventureworks DB. But what I'm trying to convey here is you have salesperson ID is created as integer here, because here I explained like you are getting the data here in this OLTP system like this, and you are creating a unique column over here, the key column. Okay, that is because in your source system you do not have primary key, I mean some integer column created for your name, for say for example customer name. They are maintaining the customer name itself instead of maintaining a key or ID. Then it will be a very complex to store in your data warehouse. So in those cases you will generate the key in your site. Okay, that is what I'm trying to highlight it here. So this is OLTP system. This is properly already designed where you can get different keys here. So this is what from this you have your OLTP system. You need to do ETL, that is using SSIS or any other ETL tools. You transform this data from this place to data warehouse. Okay, using SSIS I can say. So once you transformed, you can see the same module over here, like fact internet sales. So here there is no header or detail concept that you're transforming here, right? So here in this case of sales you have header, detail, and other sales reasons, something, some other different things. For sales header itself you have two tables, whereas once you transform it, you will define only one table here. For sales header and detail it will be merged into single table. That is the logic, that is what we need. You need to have certain kind of ETL transformation of your data to put it into here. So here you have sales header detail, but once you come here it will be sales fact internet sales, that's it. So you need to merge certain tables, you need to ignore certain records, filter it out. Those operations you can do using SSIS. That is what ETL part. So once you do that, how you your star schema will look like. There is different diagrams. As I said before, each fact, I mean each subject area, you will create one fact, or it can be one or two facts based on different granularity in each subject area. Assuming the sales subject area, you have internet sales. Okay, let's try to see this, how it looks like a star schema. Let's go for finance. It will look exactly typical star schema. Over here you see the fact finance. The ultimate aim is to convert into fact and surrounded by different dimensions. So fact table is there, you have different dimensions surrounded by it. So this is what your data warehouse is all about, creating small data marts like for each department that will become your uh, enterprise data warehouse. Again, moving back to internet sales. Internet sales, where date is connected three times because you have shipment date and order date, other dates. So 3 times it is connected, okay, using a foreign key. I mean to say, here all the date table, here the dim date will be a primary key, here the date key, and you see here date key, and you have this column. When you highlight it, it says like dim date fact internet sales. It can be one of the relationship, like you have order date, due date, ship date. So each will be different dates. So these are foreign keys. Okay, order date is one of the foreign key, due date is another foreign key, like that. Let us take this example. There is some promotions happening, so for each promotion they are creating one key, and that key is referred here. Okay, what I tried to convey in using a sales territory, right? Let us try to see it using this example. uh, um, the sales territory over here, this is what you see here. The sales territory key, again it is repeated. Alternate key is nothing but your whatever you receive it from the OLTP system. Okay, let me refresh that one. What I'm trying to convey here, you see the Adventureworks 2014 territory ID. Okay, 1 2 3 4 5 6 7 8 9 10, and this is stored in one particular table. This table is transformed into dimension. Usually whatever the master information is transformed into a dimension. This is transformed here, but you see a minor difference over here. There is another entry 11, that is fine. I will explain it in some other videos what is that. So for each, this is your alternative key, is nothing but whatever you receive it from the OLTP source. And in case of data warehouse, you need to explicitly create one key in this data warehouse. For this is nothing but your surrogate key. The purpose of surrogate key is say alternative key for you. Okay, and why it is required is like, assume instead of 1 2 3 4 over here, territory ID is some combination of characters, NWH US, something like that. So the occupancy will be more. I mean the the storage it occupies will be more. uh, that is why you need to convert equivalent numerical values, so that your storage will be very less in your fact tables. Especially this is not very helpful when you convert into dimension, because all this master informations is going to be referred in your fact internet sales, right? So you can see here sales territory 1 to 10. So there might be thousands or crores of, I mean it can be millions of records, but those millions of records storing as an integer doesn't have any impact. I mean it will have very less impact. So you see your fact table, you have all the dimension keys, foreign keys over here, that is everything is surrogate keys, and you have only the numerical values. Your fact will exactly look like this: key reference from dimension tables and due. So these are different dimensions: sales territory, promotion, currency, everything. Okay, then you have your measures. So I hope you guys understand how what is task schema, data marts, and you have different fact table for each data marts, and your task schema is nothing but facts surrounded by different dimensions. If you like this video, hit the subscribe button right now to learn the concepts in SSAS. And do remember that data is your asset.